In this video, we're going to be covering another question. Um, so this is not, this is more like a demo question than a real interview question. So what a demo question is like when you are close to an Amazon interview, um, they would actually send you a demo that okay, the questions are going to be like this. So there, in those demos, you could find questions like this. Okay, so we're gonna be just doing it on lead code this time. Basically, it's asking for the greatest common divisor of an array. So what happens is like if you have been given 2, 5, 6, 9, and 10, you wanna look for, and this is the problem statement, you're gonna be looking for the smallest number in the array, which comes out to be 2, and the largest number in the array, which is gonna be 10, and you're going to be finding the greatest common divisor of the smallest and the largest, which is going to be 2. In terms of the pseudo code, there is not a lot in here which I'll be demonstrating, other than if you have an array, let's say 5 and then 10 and 15, and you end up having a 5 as the smallest and max is 15. What we're trying to do is, in order to find the greatest common divisor, is like we're going to be recursively using an algorithm called Euclidean algorithm, which basically does is like if you have two numbers, it replaces if it comes in form of a and b, it replaces b with a recursively, and the second one it becomes a modulus of b. So it's an algorithm. I can just demonstrate how it works. So if I'm sending 5 and 15, so 15 is gonna become, whether you can send 15 or 5 or 5 or 15, doesn't matter. So if I'm sending, it's gonna, this is like 0th step, I'm sending it. Then the first step, 15 is gonna take the place of 5, and we're gonna have 5 modulus of 15, which is gonna be equal to 5. So basically the first time we did it, they just changed their position. So the largest one wanted to be here. Okay. Next time, this is gonna become 5, and this is gonna become equals to 15 modulus 5, which is gonna be equal to 0, right? Because it's gonna be completely divisible by each other, so it's gonna become 0. And while we are recursively doing that, we're gonna have a base condition where we're gonna say that when the b when the b becomes equal to 0, just return a. So in this case, the next time when it's gonna be looking at b, which is equal to 0, it's gonna be returning a, which is equal to 5. So he will just return that. Okay, in terms of looking for the minimum and max, we're gonna just have our min, and again the condition over here is that we are guaranteed that we have at least 2 elements here. So I'm gonna say that the min is equal to nums of 0, max equals to nums of 0 for every single num inside the nums. In order to find the min and max, I have to update min by saying either the min is still the min, or look for the new number and decide if that is, if that is the minimum number, it's going to take the place of max. It's going to take the place of min or max. Don't sort the array. It's going to make the time complexity log of n, n log of n, and it's going to be much more than what we just want to do. If we want to find just the min and max, we can do it in linear time. Okay, what else? So now we're going to be sending return get GCD. We said that because if you send the min first and max next, what happens is like it just for the first iteration they just change the place. So better you send max first as a first argument and the min as a second argument. Okay, get GCD is going to be returning an and A and B. The base condition is if the B is equal to 0, return A, otherwise return get GCD to B and A modulus of B. In terms of time and space complexity, we are finding the min and max in linear time, and then depending on the numbers, right, we have two numbers here, min and max here. So what we are doing is like so once you have the min and the max, right, so the maximum amount of time this iteration uh, can take is that every single time you are actually uh, you are actually get the GCD of 2, uh, you are taking the modulus of that, and then you're taking the modulus of that. So yeah, every single time what's gonna happen is like we whatever is the minimum, so every single time you are actually uh, logarithmically decreasing the time. So in terms of the time complexity, uh, it would be whatever is the minimum, right? So uh, we're gonna say that it would be the log of the minimum. And again, because we have to find the so this would be the time complexity, that in linear time we're going to be able to find the min and max, and then whatever is the minimum value of that, that would be the log of min. Okay, and we are not using any extra space. Those were the things I wanted to cover. Thanks for watching.